There we go. Okay. So it's 10:15. Good morning. Thank you for showing up, especially because this was the first talk of the day after the keynote. Can everybody hear me okay? Yeah? Okay, good. This one is about two topics that are related, but not necessarily, one is not a prerequisite of the other. And these two topics are file table, which is a new feature in SQL Server 2012, and also some full-text search enhancements, which are part of SQL Server 2012, including the well-known semantic search. And so we'll do some of semantic search. And I have way too many demos, so let's just go on. Let's see. He said, there we go. That's the slide that has me on it. Great, there's me. You now have my email address. You can write email to me if you want. You can harass me on Twitter if you'd like. There, finished. Okay. So just to go over to start with, how many people are aware of what file table is and know everything about a file table and wonder why you came here? Okay, that's not anybody. That's good. Okay, because that's what the topic is. So we'll start off with file stream, which is the prerequisite of file table. I'll do a file stream demo that takes about 2 minutes. We'll go on from that to file table, and then we'll combine file table and full text search, and then we'll go on to combine file table, full text search, and semantic search. Sound like a winner? Okay. So first of all, the idea with file table and all of this came about because there was a study done on LOBs, large objects in a database. And the debate had always been, do large objects belong in a database or do they belong in a file system? Database administrators would like to see everything in the database, for the most part, for recovery, for backup, for point in time, that kind of thing. But the problem with putting large objects in a database is that large objects in a SQL database can cause fragmentation. They also take up memory buffers in SQL Server's memory. And we all know the way to make SQL Server run as fast as possible is to make sure everything stays in memory for as long as possible. Right? You don't have to read off a disk. It runs fast. Also, there's the argument against blobs that says when you write something to a file system, you write it once, even if it's a transacted file system. If you write it to a database, you write it twice. You write it once to the transaction log and once to the database itself. So it turned out that this paper, which was done by a bunch of people, came up with the idea that the break-even point for blobs is 256K. It was Jim Gray that actually was the head of this paper. 256K isn't much. And the break-even point meant 256K, it should live in the database. Over 256K, it should live on the file system. And this is rather interesting. So in 2008, they came up with FileStream. And FileStream is a database file system hybrid, where the data actually lives, or the var binary maxes can actually live out on the file system as individual files. Whoop, come on back. Individual files. And that they appear to live in SQL Server. And if you do a select star from some table, it just knows that they're out there and goes and gets them. And let me just do a demo rather than read the slide at you, because it's way more fun to do a demo than read the slide at you. So now I have to find my demos. Lovely. There we go. And I'm just going to make a file stream really quickly over the Northwind database. So to do this, you have to enable FileStream, and I have FileStream enabled. Go into Northwind. I enable it on a machine-wide basis, and I also enable FileStream on a database instance basis, so I've enabled it here. There we go. And the first thing I have to do to enable it is to add a file group for FileStream. So there's a file group called FileStream Group 1, I have no imagination, added to the database. Now, of course, I have to add a file to tell FileStream where to map that. And so I add this file directory right here, C Files Photos, which means that the FileStream files will actually go into C Files Photos, or a subdirectory thereof. And the reason I'm doing this, and I'm doing this rather fast, is to show you how FileStream looks without file table at all. Back in my Northwind database, I make up a table called DBO Employees 2, and I've changed the photo column. If you know the Northwind database like the back of your hand, I have changed the photos column, rather than to have it be image, to have it be var binary max with FileStream. And that means it will go out on the FileStream file group. I also must have as a prerequisite a unique identifier column with the row GUID call property on it. So that's a requirement for FileStream tables as well. So I'm going to create this table. Actually, before I create this table, let me go out and show you the file system at this point. So on the file system, and I'll, zoom in a second. Under Files, there is a subdirectory called Photos. Under Photos, there's a file stream header, filestream.hdr, and $FS log. The log is actually kept for FileStream in conjunction with the SQL Server log. You can do point-in-time restore if you desire. However, all that log logs is whether or not you've changed it, inserted it, or deleted it. And for a change, all they log that on is deleted the old one and inserted the new one. No sweat. So that's the FileStream log right there. When I make a table with FileStream in it, there we go, and we'll just put all this junk in here. It shows up as 2 directories. Here's a directory, name with a GUID. That's always fun. Remember that GUID. And here's another GUID. And then under that GUID, there's nothing. So that would actually be where the files went if I put in rows. So let's put in some rows. We'll just do an insert select. And there we go. And now I have 8 or 9 or so rows of data in there. And notice that it is not a good thing to use FileStream if you're less than 256K. Well, it's 22K, so you could tell that I did this demo as a gratuitous demo for no good reason. I really should have this data on the database to start with. But anyway, now I have FileStream. To decode these GUIDs for you, basically if I start at the root of the FileStream, let's go back one more, photos. This one here represents the first table that has FileStream in it. So I can have more than one table in a database with a FileStream column. And so there'd be a directory for the first table, a directory for the second table, and so forth. Right? Each of those directories is named by a GUID. Good? Now, if I go into this directory, why is there another directory with a GUID? Well, technically, I can have more than one FileStream column per table. And so if this is the first column, if I added another FileStream column to that same table, I would have another directory and so forth. And then this is where my files live. Anybody notice anything about the files but me? They don't have suffixes. In fact, they're named with GUIDs, and you can't rename them. So this is one of the drawbacks of using FileStream. It is stored on the file system, but it's really part of the database. And in fact, I had somebody come to one of my talks on FileStream, and they wrote me mail a couple of days later. By the way, you can write me mail. I always answer mail. And said, "Dear Bob, you did a talk with a demo of a trigger on a FileStream column." So I went in and I opened up the FileStream column with Notepad, like this, right, and opened with Notepad, and I edited it. And when I closed it with Notepad, the trigger didn't fire. And I wrote him back and I said, "Really? And did you, to change the database, also edit the MDF file? Because that's a good way to change the database, too. Go in and edit the MDF in binary, and that'll work. The trigger would fire then." Once you have these things out there, realize that they are part of your database, right? If you edit these things and save them back, it's likely, though not always work this way, that you might actually get DBCC messages reporting database corruption because you have edited the database outside of the database. Well, then it sort of takes away from using these as files, doesn't it, Bob? Well, that's where we're going to get to. Everybody good so far with this? Good. Let's go on to the next one. That was a really short demo to show you what FileStream was about. And it has to be a local drive, and it has to be the MTFS file system. You can use, a SAN, as long as the system thinks it's a local drive. And you can use a NAS, network addressable storage, as long as the system is convinced that it's a local drive. If you can't convince the system it's a local drive, then you can't use it. And only var binary max can be stored with FileStream. Okay. So to program with FileStream was difficult because you had to write all your own programs. When I said to the guy, "You shouldn't open it with Notepad," he said, "Then how should I open it to be able to edit it?" And I said, "Well, with FileStream, everything has to be within a transaction. So you should use transactional Notepad." And he said, "Do you have a copy of transactional Notepad on you?" And I said, "No, but I have source code. Do you want to write it?" Right? You can compile it. And so anyway, that's the idea. It always had to be transactional because this is, after all, a database. And so you would have to write all your programs over. In fact, very few people did that. Anybody have FileStream implemented here? One person. Okay, that's good for 2 people I saw. That's good for a crowd like this. And the reason why is because you had to use these special methods here to get streaming I/O. With OLEDB or ODBC, you have to use OpenSQL FileStream, and with ADO.NET, they actually made their own class that you could use with it. However, bear in mind that this is not technically a real file as far as SQL Server is concerned, and so there's some limitations to what you can do with these. And of course, it doesn't know the real suffix for these. It's like, can I go and rename them? So if I double-click on them, it's like, no, forget about renaming, forget about double-clicking. It's a database with var binary max. Okay. So that was FileStream. The enhancements to FileStream were, in SQL Server 2008 Release 2, they now supported both of the snapshot isolation levels. They did not support those before that. Not to mean that you're going to be able to use snapshot isolation with the streamed I/O, but you can certainly use it with the SQL I/O. Everybody okay with that? So that was good because if you did have a file stream column, you couldn't add snapshot isolation, and vice versa. If you had snapshot isolation on a particular database, you couldn't add a table with a file stream column. In SQL Server 2012, they actually did quite a lot better. The limiting factor to having people use file streams, besides the fact that you had to rewrite everything, was the fact that it didn't support database mirroring at all. So in SQL Server 2012, it still doesn't support database mirroring, but it does support always on, which is basically database mirroring over more than one database at a time. Any always on people that are going to dispute that? Okay, good. It's probably more than that, right? I was looking for the argument. And you can have multiple containers per file group. So if I wanted to have a container on the D drive and one on the E drive, then I could split the files amongst the drives. Great. You can also specify max size for file stream container. So to wrap up file stream, the nice thing about it is the data is on the file system, but it's really just a column to SQL. And it's integrated with SQL Server Security, SQL Server Backup and Restore. Let's talk about SQL Server Security, though, for a second. Because does SQL Server have row-level security on its tables? No, it does not. So does that mean I can give somebody access to one file but not another file? And no, I cannot. Right? I can give people access to the column in the table down to the column level, but I can't give them access to one file in the directory but not another file in the directory when we have directories. Okay, but at least it's integrated with SQL Server Security. And you can use transactional streaming I/O for best performance. Everybody good with that? However, the limitation is it doesn't use the Win32 APIs. So it's not exposed with the Win32 APIs. So if you wanted to use these files with ASP.NET or even Notepad, they don't use with that, right? Because you would have to rewrite them over to use transactional I/O, right? And there's a flat namespace. It's not a hierarchical namespace. And there's no concept of extension. So you don't know what to open this file with unless you store it yourself, which you conceivably could. So it turned out they had something in mind when they implemented this feature. And something they had in mind came out in 2012, and it's called Filetable. In fact, let me give you a little hint, and I'll hint again later on. The Filetable and FileStream components, as well as Hierarchy ID components, came originally from a part of the system that they had built at one point called WinFS. Anybody remember WinFS? So now we have somewhat similar to, but it's not WinFS really, it's just the table, okay? You can have a hierarchical namespace with file table, and you know, I can't really talk anymore. Let's just make a file table. Everybody happy with that? Let's make one of those. Because it's much better to, but remember that it does use file stream underneath. So under scripts, under blah, 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 then we go here, and okay, let's do the simple file table demo. So I'm going to create a database called file table demo, primary file group. I have a file group for file stream. And this is what's new with respect to file table. File table can do non-transactional access through files as though they were in a file system. In fact, SQL Server has gotten together and made a Windows namespace extension, so they really are a part of the file system. And so in this case, I specify non-transacted access equals full, which means I can either use transacted access or I can use non-transacted access. When would you use non-transacted access? With any program that you didn't write yourself, right? How many people have transactional file stream built into their programs? Well, there's SharePoint, okay. And that guy over there, right? So, and also a directory name, because what they're going to do is they're going to use this to be able to synthesize something that looks like a share. In fact, it's such a good share that the antivirus products think it's real. Okay, so there's my database with my special things in here. And there we go. So you can also specify, by the way, non-transacted access equals read if you want to, or none if you only want transacted access. None is the default. So now I'm going to make a table that's a file table right here. And that's all you really have to say. I'm going to create a table called documents as a file table. And Filetable is basically even more of a file system database hybrid. I specify the directory of the share that I'm going to get with my file table. And indeed, I can also specify the collation of the names of the files that I can use with it. So it'll use whatever collation you would like with the names of the files. So once I've made one of these, I just got a question today that said, okay, I've made one of these now. How do I find what share they made up? Because I've given them enough to make up a share, and a file table will actually make up a share. And I don't usually use the GUI, right? This is the GUI that I use. But an easy way to do this with the GUI is go refresh the GUI. There we go. And is it going to refresh down to there? Yep, there's file table demo. Okay. That's my database. And if I go there and I go to tables, lo and behold, come on, where's my, oh, don't tell me. It's not very happy to use my zoom it tool. Really? There we go. I don't know why it didn't zoom it before. Okay. So if I go down to here and there we are. Go to file tables over here. I can, he said, come on, stop that. I can right click on the file table right here and it says open explore file table directory, second for the top. Right? And that basically, when you click it, will open up the directory that it's made up. And you can see that that directory is just network, the name of my machine, which is ZMV03, the name of the instance of SQL Server, which is MS SQL Server, I'm running the default instance, and the name that I gave the database, and the name that I gave the file table. Sounds reasonable? So let's put some files in it. Really? That's all we have to do? Can I put files in it using SQL? Yes, you can. But it's much easier to go here and do this. And so we'll make up a new text file called sumtext.txt. I have no imagination. And we'll make a directory called SQL Server. And we'll make a file under that called, I don't know, like I said, I have no imagination, sumfile.txt. Okay, there we go. So now I can actually go out and look at that file table. I could have looked at it before, but it had been empty. And when I do select star from documents, there's my table. Now, my table does, as far as SQL is concerned, have fixed set of columns. You cannot add columns to a file table. However, you can use any of the keys of the file table to actually tie it to other tables that you have in your database. So, for example, if you had a table with additional metadata or additional information about every file, you could just hook that up through a primary key, foreign key relationship. Everybody good with that? The stream ID is actually the GUID that's required by file table, or file stream. The data actually lives in a column called file stream. And because I made up empty files, they're empty, except for the directory, which is null. There's a short name for this, and two path locators, a path locator for the main path and a path locator for the parent. Notice that those two that are in the root have a null path locator. And what are those path locators? They're hierarchy ID. Did you ever wonder about the reason for the hierarchy ID? I think they had this all in mind to start with, right? And indeed, the rest of the columns in here, notice they do have the file type, which is nice, are just the type of columns that you'd actually find on a file system. And these files get manipulated either by the file system or by transact SQL. Sound reasonable? That's all there is to it. So can we do anything interesting with these? Well, one of the things that it says is that a delete fails on a directory that has files in it. It's not actually going to prompt, do you want to delete that directory with those files? It just fails. So, of course, I had to try that. And that works just fine. Notice it says the delete failed because we have a referential integrity constraint. If you want to know how they actually did file table, go down here under Documents and look under Constraints and look at the constraints in here. They're enforcing everything with constraints. As far as the system goes, the Windows operating system, they are their own Windows operating system namespace owner. Everybody okay with that? That's the name for it, right? They're the namespace owner of that part of the file system namespace. Okay. Now, I've used this to solve a problem that I've had for a long time. It works to actually delete a document. So there we go. Anybody use XML? I can get XML files into SQL Server. How do I get XML files into SQL Server? Open Rosette bulk with either single blob or single clob, single blob, or single enclob. But once the file's in the database, how do I get stuff from the database out to a file? Well, that doesn't exist, right? I call that feature, all your XML belongs to us, right? Once you put the XML in SQL Server, there's no way to really get it out into a file anymore until the file table comes. So it turns out that I can go do a select, and I'm basically selecting XML out of the Human Resources Job Candidate table in AdventureWorks for job candidate number 1. And what I'm going to do is I'm going to change the name of this to a synthesized name, which I made up, job candidate 1.xml. And I'm going to put the resume in a var binary max column. And then I'm going to do insert into documents, name, and file stream. And basically what that'll do is that'll surface that XML from the database as a file, really. So all your data doesn't belong to us anymore. And there we go. And now I can go back out on my my real file system, and that real file system should be there someplace. If I did refresh, which I should be able to do somewhere, do I need to refresh out of this? Well, I'll go back and do the obvious thing. We'll just open it up again. There we go. And there's my job candidate 1.xml. And so now I can produce XML or anything else in a file from the database. So it allows me to get my data back from the database as files if I want to. Nobody's particularly impressed. Huh? Okay. I'm sorry. I thought it was cool. All right. There are also ways that you can get friendly names from this system so that you can actually use them as if they were paths. So people want to know what the name of the file is so that they can go out and read it. And you can get that with a SQL query. There's a couple of different ways to get that. One was called get file namespace path, and that gives you the path. This one actually gives you the root of the file table. There's 3 overloads of this one because it turns out that file table actually works with always on. So since I don't have an always on right in front of me and I'd have to switch between VMs, let me tell you my always on demo. I went into always on and I made a file table, and sure enough it showed up on both places. I thought that was kind of cool. And it shows up in both file systems. And so then what I did is I opened a file in Notepad and I started to edit it. And then I failed over from one database to the other, right? From one instance of the database to the other. And I was going to, it's like, all right, what happens now? So what happens now is that I'm editing. It comes up with a dialog box that says, one of the resources that you need to do your editing is no longer available. Then after it fails over, that dialog box goes away. I continue editing, and I can save it. And I'm happy, right? So you can actually use this with always on. And you can use this with virtual network names of always on. So if I have a name which is the same if the file is over here or it's over there, I can use this perfectly. There is also a way to use this file table to get rid of locators. Anybody have locator columns in their database? Locator was actually a data type as of SQL 99. SQL Server didn't support it. But a locator is just basically the name of a file on a file system, on a real file system, put into a database, right? And then you try and keep those in sync by whatever method you might want to do. And so this get path locator is actually going to get you back a hierarchy ID that corresponds to the place in the file system where your file would be. So if you want to be able to take locator columns and turn them into file table columns, this will get you the appropriate hierarchy ID to do the insert. Everybody sort of get the idea of that? Okay, great. Now, just to prove to you that there's no magic here, there's always magic. There's my files directory. There's my file table demo directory right there. And there's my file stream file group. It's still there. My files really look like they're here, and they're there. There's my real files, right? Somebody goes, well, I tried to edit those files. Don't edit those files, right? If you want to edit the files, edit them through streaming I/O by using the file system. The file system works just fine. The file system is also aware of the suffix you want the file to have, whereas this isn't aware of the suffix at all. Don't touch that. In fact, DACL that so that the only person that has access is the SQL Server service account. Keep people out of that, right? You wouldn't let them in your MDF file. Okay. So that's just to say that a file table is actually really a file stream implementation under the covers. Also, if you thought of doing this, I did, you can't make a file table over an existing share. So if I had a zillion documents someplace out on a share, I couldn't say, point the file table there. what I would have to do is make a file table and drag all those documents into my file table. Then it would work okay, right? But I can't make a file table over an existing share. Too bad, because I thought that'd be nice. Alrighty. Oh, and by the way, just for your entertainment, I wrote blog entries about how this worked, but I decided I would like to try and synthesize. These are all in the blog entries. And by the way, you can use hierarchy ID on file table if you're really a masochist. Is that right? Yeah, masochist. Okay. There's hierarchy ID. This is the way they actually get the path locator, the hierarchy ID value from file table. And where I actually got that was by looking in the appropriate constraint to see what the default was for that particular value. So that's actually how they get that particular value. Unfortunately, you can't have, I wanted to make this into a function, but a function cannot contain new ID. So rather than making it into a .NET function where they don't check, I just use it everywhere I have to use it. So this will make up the path for you if you want to play with these things in SQL. And so you can insert a file under another file and so forth. That's what this is about. Okay, but the world's cheapest, easiest file table demo. So file table, again, has Win32 access and has a hierarchical namespace. It's a fixed format table. It's SQL 2012 only. And the hierarchy ID columns just basically make up, as far as SQL Server's code goes, something that looks like a hierarchy, but really you just saw the underpinnings of it. It's not a hierarchy at all. It's a flat system. It's available as a file table share or as Transact SQL table. You can work with it either way. And you can maintain it through the share directly. And through the share, you're getting non-transactional access. Unless you write your own program, right, drag and drop is not going to be transactional. Right? I'll show you the new bulk copy with this coming up. Right? You could probably guess the new bulk copy is drag and drop. Right? Works good. But drag and drop is not going to be transactional because the Windows Explorer is not transactional. They do not use the same transactions as file system uses. To set it up, was everybody happy with how we set it up? You need the database to point to part of what the share name is going to be. You need to create file table, and that points to the other part of what the share name is going to be. And you have to allow non-transacted access if you want it. There is no, must-have for non-transacted access, but normally that's what you want. There's the columns in a file table. I'm sure you all wanted a list of those. They were glommed out of the books online. Again, the only one that's interesting, I think, is just the file _ stream column, which is where the stuff lives, right, the actual data. Transact SQL Access has a couple of weird things about it. With insert, you really only have to insert 2 columns. The rest of the columns have defaults, and they're reasonable defaults. And you can't name your own hierarchy by actually naming the hierarchy. You can't insert into some of the hierarchy ID columns. You can't make your own hierarchy that way. You have to tell it what your parent is. You can update the stream without changing the date time of when the file was saved, if you really want to do that. I would sort of more consider that to be a drawback rather than a good thing. And if you use the var binary max write method, there is no write method supported for file stream or file table. Delete fails on directories containing files, you saw that one. And BCP, you can use BCP if you really want, right? But the new BCP is like drag and drop. Just take the files and put them in there, and we're all set. And the other weirdness of it is that select into with the file table does not create a file table. So if you do a select into, it will create a real table with those columns in it, if you care. Programming functions. So we saw the get file name path, we saw the get root, and the path locator. Again, the path locator is just if you have existing path locators, you can translate them into hierarchy IDs. If you don't have existing path locators, forget that that function even exists. It's totally useless to you. Triggers. So triggers file with SQL or file IO. So the guy can actually go in with Notepad and edit his stuff in Notepad. There's some trigger limitations. Let's go put a trigger on this guy. So here we have this, just to show that it'll work this time. And then somebody can write to me and say, "Dear Bob, I saw you put a trigger on a file table, and it worked this year. How come?" Okay, so there we are in file table demo. I'm going to create a trigger foo on documents for delete. And when I delete something, it's going to raise an error that says row deleted. I have no imagination whatsoever. Right, so there's my trigger. And then let's go out to the file system. And where do I go for the file system? You start to memorize these after a while. name of your machine, whack name of your machine, whack MS SQL server, because it's the default instance, whack, what was the thing that I had here? File table demo. And it's not going to help me, is it? All right, so we'll do it the easy way. There. Okay, let's delete this file. Delete file. Great. Did the trigger fire? Well, all we have to do is look in the SQL Server log. And I want you to trust me that this, no, I don't. We'll just go into the SQL Server log. Nobody trusts people in demos anyway, right? So let's see. So management, SQL Server log, there we go. And we'll look at the current SQL Server log, and there it is. Right, row deleted in documents table. Great, that's what I wanted. So you can actually do that. That's great. File table share behaviors. So even the antivirus programs think this is real. But realize that this is completely synthesized, the share, by SQL Server. So if you bring SQL Server down, the share goes away. Yes, sir? Can you prevent deletion of a table by doing that? Yes, you can. You can prevent deletion. I believe you can prevent deletion of a table by doing that. I have to see. The reason why I just took it back was because it's non-transactional access. And so conceivably, let's see, rollback does not roll back updates to the stream, but I bet I could prevent a delete. So my answer really is I'll have to work on it. I'm not allowed to lie or guess, but I'm almost certain that you can prevent a delete that way. Notice I said almost. Okay. The big thing about this, as far as the security point of view, is it is considered not a best practice in SQL Server to allow some of these ports to be open that you need to be able to access file tables and streaming I/O. And the big one is port 445, which is the file sharing port. So you will have to open port 445 and port 139, which is the COM name resolution port, to be able to use file table in sharing mode. Again, you're opening these ports on a local SQL server. So if somebody said, yeah, that's against the security best practices, I wrote the security best practices white paper. Yes, it is. It's against security best practices. But since it uses the SMB protocol, that's really the only way to do it. There's some limitations to it, the biggest one being that memory map files are not supported. What's a memory map file? Well, it's a file that will actually be instantiated in memory. And one of the things that uses memory map files, unfortunately, is Notepad. So if I go into here and I actually make a file, there we go, text file, and then I open it in Notepad, as long as it has no data in it, it's fine. We'll put data in it. We'll save it back out there. Great. And now we'll go out and try and open it again, and it comes up with a lovely error message. This request is not supported. Right, because they use memory map files in Notepad. The other one is Paint. So if you want to get around that, just actually take and mount that share as a network drive letter. So if I was to go out and mount it as a network drive letter, then I can access it with Notepad. So if I go out on my network and do that, I'm not going to do that right now. But you can access it with Notepad. Be aware of the fact that the other person on the other end of the thing has to know about that drive letter as well, or map the thing as a drive letter. Okay. There's a limit of 15 levels of subdirectory. And this is a little known fact about Windows, but the NTFS file system allows file names up to 1,024 characters. Windows only allows file names in Explorer up to 260. They truncate them. So you can make your file names whatever they want, but realize they're not going to show up more than 260 in Windows Explorer. But that's a limit of Windows Explorer, not a limit of file table in general. Concurrency. So whether or not you are using snapshot isolation, the file part of the file I/O always uses read committed semantics. In other words, I'll go in, I'll be able to change something. If you want to go in and change something at the same time, you won't be able to change it if I have a lock on it. However, do remember that a lot of these programs like Notepad do not lock files when you're reading them, right? You can open two files in the same Notepad and it'll just work. Right, in two different notepads, and it'll just work. So realize the semantic of the program you're using as well, as far as concurrency goes. And the reason I said this is I tried to actually come up with a nice demo to show the locks that were taken on a file table, but I actually had to write my own program to be able to do this that would actually take an exclusive lock on the file when they edited it. So once you do that, you can see the locks that these things take. During read committed or snapshot isolation type transactions, if you are doing an update with read committed or snapshot isolation, transact SQL or transacted Win32 will fail unless they specifically take a read committed lock. So you must have a read committed lock, else those will fail. And the reason why this makes a difference is because snapshots, database snapshots, and always-on read-only secondaries always use the equivalent of read-committed snapshot isolation behavior. So if you're going to use these with read-only secondaries and always-on, be aware of that behavior. Always do your transact SQL with a read-committed lock if you care, or be prepared to catch the error that happens. Sound reasonable? Anybody have any questions on file table before we go on? Okay. So like I said, these two features aren't necessarily related, but they're related enough that I thought it would be nice to have them in the same lecture. So this one is full text search. And you could probably figure out how you could use full text search with file table pretty easily, right? Can I full text search over a var binary max column? Yes. Can I full text search over var binary max in a file stream? Yes. So I should be able to full text search over a file table. Yes, I can. It's a real easy thing to do, to just grab a couple things and put them in a file table and then start full text search over top of them. So I'm going to do a full text search demo coming up. That's going to be a pretty easy full text search demo that I rigged up in about 5 minutes at home. So you can do character-based column search. You can do a search over a var binary column. And in fact, you can do a search on multiple columns in the same table if you would like. You have one full text search index per table, and that one full text search index can have multiple columns. If you have multiple languages in full text search, it is better to put all the documents for language A in column A and all the documents for language B in column B. And the reason for that is that you can full text search with a specific language, but only on a column-wide basis. Or you can full text search with locale ID 0, right? Locale ID 0 is for things that either don't support full text search or I have more than one language. Everybody good with that? I can also full text search over XML. When I'm full text searching over XML, this is the only one that you can do a multi-language search with. It will actually use the XML lang attribute to tell it what language this particular document is. Full text search functionality is sort of like on steroids, but it contains simple terms. I can search for a term. I can search for a prefix, but strangely, I can't search for a suffix. So if you want to search for a suffix, the requirement now is that you store your data backwards as well. So you can search on a prefix. I didn't do this, right? Inflectional terms, so I can search for run, running, and ran if I want to. You can also have words near other words or phrases. I'll talk about that. Ranking documents by relevance, so you can say how much does this use this word. Everybody's seen the web pages where they say Java, Java, Java on the top of the web page, so they'll get hit by the search engines. Nobody's ever done that but me? Come on, it must be early in the morning. Okay, or you can have weighted values, such that I have, if this word appears in column A in this full text search index, it has more weight than if it appears in column B. Good? There's a few changes in 2012. The first change is that the internals have been almost totally rewritten, but I'll get to that in a second. The way that they break words in a document, in other words, what's a word, what's a sentence, what's a paragraph, are called word breakers, and there's a word breaker for every language. There's quite a number of word breakers in full text search now. I believe there are over 60 of them, and some of the word breakers have just been updated to correspond with Office 14 word breakers, I believe. And those word breakers are the ones that I've listed here: English, Danish, Polish, and Turkish. Basically what they did is they replaced components with new Microsoft components. And if you want, it's documented what the differences are so you can revert to the previous version. One of the things that the English word breaker does now that it didn't used to do is it can tell that an email address really is an email address, right? bob@foo.com actually shows up as one word that you can search on rather than bob and foo and com, which is, I think, a good idea. There are new word breakers for Czech language and Greek. I actually have a Greek demo someplace in here. It was interesting when I made up the Greek demo with Greek documents. When I tried to zip it up, it didn't like the Greek letters in my zip file, which I thought was kind of strange. Anyway. And full text search uses stop lists, which were also called noise word lists, thesauruses, which are actually ways to do this equals this, right? You can search for Bill Gates or you can search for multimillionaire and it'll come up with the same person. And filters, you have to have a filter for every document type that you want to process. So if, for example, I want to process PDF files, you have to have a filter for PDF files. It doesn't come with the system. However, Adobe has written one. These are also called iFilters because the name of the COM interface that you have to implement is called iFilter. But be that as it may, you have to have a filter for all the documents. Now, strangely enough, they included all the filters for most of the file types that you would use, except for the Office 2010 filters, which is kind of strange. It won't index, for example, an XSLS document, or it won't do a docx document. And so the way to do this is to actually go out, find these filters, one-word search, right? Find the Office 2010 filters and install them. And I'll show you how to do that. Once you've installed them, you tell Full Text Search to refresh its list of components. And since this is COM, what does it do? It goes out and reads the registry, remember COM, and all the ones that have iFilter are actually put in there. Okay. Stop list is still per Full Text Search index. Thesaurus is one per instance. So you can't have a different thesaurus from this Full Text Search and this Full Text Search. And in SQL Server 2012, they also added property lists to Full Text Search. So rather than go on anymore, because I can see people either getting glazed over or bored, let's do a demo of Full Text Search. And since this was Holland, what this is going to be is a demo of Full Text Search using Filetable with Dutch folk songs. Lyrics of Dutch folk songs from the 1600s. And if anybody knows any of these folk songs, feel free to sing along when we get to the demo and we search for them. So this is the easiest way to do it. This is how I rigged this demo in about 5 minutes. Go out to the internet, find documents in the language that you intend to support, translate them so you don't get embarrassed, right? And then once you've done that, then you can take the original document and cut and paste it into a Word document. This actually comes from a Dutch folk song database that's out on the internet. And so that's what I did. Notice we have the same file stream and file table over here. So I'm going to create a database called Dutch Lyrics, and then we're going to use that database. And I'm going to create a file table there. And what do I do once I create a file table? Well, let's go with the new modern bulk copy. So here's the Dutch folk song database. You guys haven't laughed once this morning. Come on. There we go. This is supposed to be, after all, technical entertainment. Where's the Dutch folk song database? I don't see Dutch Lyrics at all. Oh, there it is. I just can't see. Right? Okay, so there we are. So what do we do to be able to get there? Well, we right-click. Whoops. Go down here. Tables, File Table, right-click, Export File Table Directory. Great. It's empty. So let's go over and get my Dutch folk songs. They're right over here. Sorry, in Explorer. We'll go over here, and go over here. And there we go. So notice there's some Dutch folk songs, not a whole lot of them. And we'll just bulk copy them in there. Now they're there. Okay, cool. I can actually go now and look at those in the database if I want to. So select star from songs would be fine. And indeed, it works just fine. There should be a bunch of songs there. Great. And they know the names of the songs and where they live in the hierarchy and all that good stuff. Great. So 5 minutes. It took longer to find the songs. Now, I'm also going to use this to demonstrate property list. Basically, if you don't know what a property list is, go to the Windows file system and choose anything, let's see, here's one, a Word document. And if I choose a Word document and I right-click on the Properties menu, what I'm actually going to get, come on, are you done? There we go. What I'm actually going to get here is a set of what they call extended properties in the Windows operating system. And so there's extended properties that are exposed on Word documents. They're exposed right there. And so what I want to do is have Full Text Search be able to search on those particular properties. Why? Oh, because that's what some of the song players do. That's what some of the other applications do, is to search on those properties rather than on specific file names in the file system. Right? I have what do you call it, story about that, but I think I'll forgo that story for a second. Okay, so now that I want to do that, in fact, some of these do have properties. Let's go to the Dutch songs. Those were Gaelic songs. There, we have Dutch songs here. And if I go to properties and I look at the details of this, for the author, they have the Antwerp Songbook. So the Antwerp Songbook is where this guy came from, and I'll be able to search on that. So to do this in SQL Server, you have to go out and find the properties you want to support. And let's see if this will actually go out onto the internet and find them for me. Oh, wow. Not only will it go out there, but it'll go out in, there we go. And it says window properties. And when you go out there and look under, say, communications or computer or calendar or audio, let's look at audio. There's a list of the properties that they will support. And each of these properties have a GUID, that's the format ID, and each of these ones have a name, that's the prop ID. By the way, before I noticed this and actually wrote a blog entry about it, this page actually used to be called Properties Supported by WinFS. Once I wrote a blog entry about that, they changed the name of it. I thought that was nice. That's where these weird GUIDs come from. So we'll create a search property list right here, and we'll add some properties to it. So I'm going to be able to search on title and on author and on keywords property. There we go. I can get some metadata about these, so registered search properties. And there's my 3 registered search properties. And registered search property lists. Not a big surprise there. And I can associate a search property list with a full text search index. So let's go in here, now that I've got my files all in a row. And what I want to do is make sure that full text search supports Dutch language. That's locale ID 1043. So if I do a select star from full text search languages where name is like Dutch, it sure does. It supports 1043. However, if I go and look to see if they support the new Semantc search feature, they do not yet. If you want a Semantc search feature for Dutch, which means I'll have to do another demo for that, if you want a Semantc search feature for Dutch, I'm going to put up a connect item, and everybody can vote on it. I decided that that was a way to allow people to do that. If I don't look for names that are like Dutch, they do support 19 languages, I believe, in semantic search in this release. Let's see if that's right. 15, I lied. See, that's why I'm not allowed to guess. And they support 15 languages. 6 of them are Chinese. So if you're from China, you're in luck, right? If you're from Holland, you are not yet. All right. So first thing we have to do to create a full text search index, how many people know about full text search? No? A lot about full text search? Oh, 3 people. So 3 people knew about full text search, 2 people knew about file stream, and you came anyway. Thank you for coming. I'm honored. Right? So the first thing you have to do is create a full text search catalog. This catalog idea was sort of much more mainstream when we actually stored these as files in the file system. But a full text search catalog is just a container for full text search indexes. Everybody okay with that idea? And the idea is that you can rebuild the full text search indexes associated with a single catalog. So I can say rebuild the full text search indexes associated with catalog X. I can also have a default catalog, and I can say at a catalog level whether accent sensitivity is on. That's basically all catalog does these days. So I can create a full text catalog as the default catalog. There I go. And the next thing I want to do is be able to create a unique index, because full text search requires a unique index. Now, the strange thing about this is that they will create a unique index over the stream ID, which is a GUID column, unique identifier column, which may not be the best thing to have a unique index over, especially if the GUIDs are not in order. But be that as it may, with a fragmentation of 99.9, you can create a unique index over these. Strangely enough, the first demo I saw that looked like this actually had this unique index created. It's created by default anyway. And the only reason I figured that this guy created a unique index was so that they could use the name in the definition of the full text search index. So if you do not want 2 with the same index, go and look up the name that they've created for your unique index and use that name. In other words, let's go do that, because I can see I'm losing people right here, right? If I go and look at that particular table, there we go, DBO songs, and I look at indexes, there we go right here, notice what they call the name of the unique index, UQ songs and some GUID after it. So again, you can go harvest the GUID and then use that in full text search. This is actually creating a redundant duplicate index. Okay. Then we'll create the full text search index. I want to tell it what column I want to use, which is the file stream column, right? The one where the stuff is, the actual document is. And then I want to say this is file type is actually the file type column. That lets you know which filter to bring in. So if the thing starts with or ends with PDF, then it'll use the PDF filter. If it ends with docx, then it'll use the docx filter and so forth. And of course, file stream or file table nicely has that column set aside for you. I'm going to choose this to index in Dutch language. And there's my key index that I need, and I'm going to specify my search property list. So there we go. And it's so fast that it will index while I'm sitting here talking. So 0 should mean, it's getting there. There, 0 should mean that it's done, and it is done. By the way, if you haven't used full text search before, it can eat your machine during indexing. So one of the things you can do with full text search is you can define one, but wait to index till later on. And that's a property on the create full text index DDL statement. Okay, so let's do some searches on this now. So you can help me along, people that can speak Dutch. Tell me if I got this right, or actually tell me if the translator got this right. If it didn't get this right, I'm blaming this on the translator, which I won't tell you which translator I used. So I'm going to go look for Dutch folk songs for this word, which I believe is princess. Is that a correct? Is that the right word for that? What? Okay. That's why these songs come from the 1600s. So how many songs contain the word princess? Oh, 3 songs. Okay, great. So now I know how many songs contain that. How about this one? Schön. Schön I looked up and it said beautiful or fair, right? So I should be able to look for fair princesses, and we'll see if we have any fair princesses or not. But first let's look for fair or beautiful. Of course, I probably mispronounced the word, which everybody up there that can pronounce it will be upset at me for that. But there's 3 documents that contain the word fair. Now, of course, what I want to do is something unfair, right? First of all, we'll also look for this that turned up to be in a lot of these lyrics. And this is actually the word for shoe. So, okay, I got princess, shoe, and fair. For shoe, how many people do I get? I get 3 for shoe. So let's look for princess or shoe. So if I have 3 princesses and 3 shoes, I get 6 songs. And it's not going to select the song over again. It's just, it's an or predicate, right? No big surprise. This is the one that sort of surprised me. So look for princess and fair in the same song. You would think you would have a lot of fair princesses, but apparently in the 1600s they were only 2. So we cut those down to 2. So, see, that's what I'm going to do. I'm going to see how many princesses with shoes I have. So let's look for princesses with shoes, or, and what's this word? Sorry? Oh, beloved. Okay. So we want either beloved princesses or princesses with shoes. Right? And there we go. We're still at 2. Right? So it's the shoe thing that actually gets the princesses, not the beloved or the fair thing that gets the princesses, which is interesting. You have to go back now through the documents and figure out why they didn't think there were fair princesses. Okay. So now that we have princesses and shoes, let's talk about the new near operator. So the near operator in full text search before 2012 basically used a fixed algorithm, and unless you had really long documents, if it was in the document at the beginning and the document at the end, near returned true, which was fairly useless. So in this version of SQL Server in 2012, you can specify how many words between you want when you do a near search. So this is, I want princess and I want shoe, and I want princess to be within 5 words of shoe. By the way, those 5 words count noise words. Right, so if you have noise words, those still count. And this false says that I don't care if princess comes before shoe or princess comes after shoe. It's no problem to me. So if I do that, I get 1 within 5 words. And let's see if the princess comes before the shoe or after the shoe. So this is the same query but true. Princess should come before shoe, and it doesn't. So here, princess must come after shoe. That only makes sense. There we go. So that's the new near operator, which is much more precise than the old lousy near operator. Okay. Property-based search. So this is the way to do a property-based search with full text search. By the way, if you haven't done full text search before, full text search comes with 4 verbs. The 4 verbs are called contains and contains table, and free text table. What free text and free text table does is look for words anywhere. So if they're properties or if they're words, it'll look for them there. If they're in the document at all and in the thesaurus, which is harder to say than it sounds, if they're in the thesaurus, then the free text will actually do a thesaurus search. And basically what it's doing is an and search for each word, A and B and C. It's not doing a search for a specific phrase. With contains, you can pick and choose what you want to do. So you can say, I only want to do a property-based search, or I only want to do a thesaurus-based search, or I only want to do a rating-type search. So in here, I say where contains property, and where the author contains the word Antwerps in it. And again, they all came from this Antwerp songbook, so you'll see that I have quite a few of them there. This is the property in the Word document itself, which means I can do property-based search. I can also look for the title, and if the title contains that word, then I'll get that title. Great. And by the way, if you ever need to do this demo again, this is how you would find words to search for. And basically the problem I've found, and I've done this in a few languages, of searching over songs, is that songs normally, in general, have really simple words. And so to search over songs is not that much fun, unless you want to see how princesses relate to shoes. Right? But there's all of the keywords that we have in here that you can search on them. And notice that some of these have to do with parts of the Word document, normal ... which is not something I'd really search on. And notice these are a lot of words that seem like they're noise words. If you want to call out the noise words, get rid of them, then you can say, don't show me noise words in here. And that will actually get you a smaller list, but it'll take longer. Okay, so anyway, that's how you would do this with full text search in a file table to search Dutch song lyrics. On to the next thing. Sure, I got 19 minutes. This is good. So the big thing that they did in full text search in 2012 was they chose to improve the performance. Apparently there are some very big customers that use full text search, and they want the performance to be good for large numbers of documents. And so what they did in this release is they went in and rewrote the internals of how full text search works. Not so much how it's manifested. I can show you the internals later on if we get there, but how it works. So now full text search has its own query plan. It's parallelized, and it has less locks during the build. So it basically scales linearly up to 350 million documents. Somebody goes, well, I have 100 million documents a day. Well, that's just 3 days too many, right? But it scales up to 350 million documents. The index building speed is a lot quicker now than before, because the big part of the way the full text search index builds itself is called a master merge. What full text search does, I'm sorry, I have to go into internals, right, at this point. The way that the full text search manifests itself is as a set of internal tables. So if I say select star from sys internal tables, there we go, I'll see the full text search tables right there. They're internal tables, which means you can't touch them. And notice this internal table is named IFTS comp fragment number of the table underscore some number. That is called a fragment of a full text search index. The reason for having these fragments is that full text search index doesn't ever update itself. If you actually update a document, what it does is it puts out another fragment and says this fragment is the correct fragment to search for this document. So if I put enough documents in there and I was indexing as I went, I would have fragment 5 and fragment 13 and fragment 8 and fragment 3, and they just keep piling up. And the more fragments you have, amazingly, the more fragmented your index becomes. And so therefore, one of the ways to make a full text index search faster is to do what's called a master merge. Master merge basically takes all these fragments, gets rid of all the old leftover stuff from the updates, and then puts these fragments together. And that used to take forever and a day, right, master merge? Now, it turns out in 2012, master merge can be parallelized. So that speeds up the indexing quite a bit, and it makes it more viable to do master merge more often, which means the index will be faster. It also used to have a problem where it would take too many locks when it was rebuilding the full text search index. So in full text search in 2012, it has more granular locks during the build, and it has a more granular build. So basically, if you're actually building the fragments, it won't build them so if you stop the build in the middle, all your work will be for nothing. You'll actually be able to at least get part of your work in this master merge rebuild. Everybody good with that? This was a big deal. It used to be that if you had a full text search index and you were rebuilding it, you might as well forget about queries while the thing was rebuilding. Now it's nice and fast. They also rebuilt the query processing of this. Basically, this thing now has its own query processor. And the queries in full text search are orders of magnitude faster than 2008. By the way, they not only had to compete against the web searches, right, Google search or Bing search with full text search, because somebody said, why would you ever use this if you have Google search out there? Well, do you really want a Google search on the web over your internal documents of your company? Probably not, right? So you might use that for that reason. The other question that people ask that I have a hard time with is that SharePoint now comes with a search engine of its own called FAST, the FAST search engine. So the question is, when do you use the FAST search engine in SharePoint, and when do you use full text search? Full text search actually has better integration with the rest of the database, but FAST is faster. So they had to make this faster as well. So the idea with the rewrite is, with the new query processor in full text search, the worst case search time is less than 3 seconds for up to 350 million documents. And they accomplished this with, like I said, a rewrite of the query optimizer and also predicate folding. So if I have contains 1 and contains 2, that folds down to contains 1 and 2. And there is only 1 contains. I have 14 minutes left to go. Faster search time with the full text search, this is called streamed table valued function. So full text search always manifests itself in a query plan as a streamed table valued function. And this function can now be parallelized itself. There was no parallelization in full text search before 2012 on a query. It's also optimized for a select top N query, because that would be what you'd be most likely to do in full text search. And let me just show you a query plan just to show you that I wasn't making this up. Let's go back and we'll look for princesses again. Where's princesses? Oh, they're up there. Okay. So if I go and look for this with a near operator, that's fine. And we'll turn on a query plan over here. There's the actual plan. I didn't get any, but that's all right. There's the query plan right there. And what the query plan shows up as is this table valued function called full text match. And regardless of what you pass into it, it's sort of strange that that table valued function always looks the same. So starting in 2012, I'm going to preempt myself so I don't miss this part. Starting in 2012, there is an extended event that will actually show you the full text search part of the query plan. In other words, the part of the query plan that corresponds to table valued function full text match. And I want to show you this because it's fairly interesting. I can go into extended events in 2012, and I have an event session that's going to go and get stuff for full text trace. And I just wanted to show you this event session really quickly. There we go. Events. And notice the events that it's able to pick out. The full text query exec stats are the ones that are actually going to get the full text search query plan. And notice there is even a full text query recompilation that you can get when the full text part of the engine recompiles itself. Okay, that's if I put in more documents. So we're just going to fire this up. Everybody's seen extended event session? We'll start the session. And then what I want to do is look at live data as I'm going through. And then as I'm going through, what I want to do is do a full text search over here. There we go. And if I can't get this, I have a way to fake it. So we'll go look for princesses and shoes again. There we go. And now this should show up. There it is. And this is the statement starting, statement ended, and here's the full text exec stats right there. So if I go look at the full text event stats right here, it turns out to be, he said, where was full text event stats? Here again. There it is. It turns out to be a file of XML. And so basically you can decode this file of XML just the same way you would decode an XML query plan. Of course, does anybody actually decode an XML query plan in XML? Well, not yet, but you can decode this in XML. And basically you can see what they're doing is a contains table ranked for near, and then they're filtering it with a single fragment docID filter, fragmenting it with the seek filter, and then looking for the keyword equals princess. Notice they also talk about how many scans they have in logical reads and physical reads. So it's the same type of information that you would get in a query plan. Unfortunately, there's no cool GUI visualizer for it. When you write the GUI visualizer, just right after you write the transactional notepad, you guys can let me know. And I will show your GUI visualizer next week. Everybody cool with that? I thought that was really nice. Right? I spent a long time studying these silly query plans. Okay. So there we go. Property list. Everybody knows what a property list is now. Property lists are used in contains and contains table. The filter, the iFilter, must support the properties that you want to get out of the property list. So Unfortunately, the Office filters for Office 2007 documents do not support property lists. However, the Office 2010 documents and the PDF filter does. So if you want to use property lists, your best bet is to actually install the Office filters for 2010 and then search over docx files. Everybody good with that one so far? And if you have any trouble with the filters, there's a trace flag 7603 that actually allows you to see what's being filtered out and what properties are being filtered out and what properties might be filtered out, but your filter doesn't support those properties. Everybody good with that? By the way, do not leave trace flag 7603 running in production. At least if you do that, don't actually show people what it's doing while you have it on. It's quite expensive. Okay, we already talked about how to use property list, so I'm going to skip this one. And we already talked about the custom near predicate, so everybody's happy with that. So the last thing I want to show you is the semantic search part of it. And semantic search was basically based on a study that somebody did about how people use the web. And so they said how you use the web to search for something is like this. The first step in using the web to search for documents is to do what? Type keywords in, and you get a list of pages that contain that keyword. Usually they're ranked on how often they contain that keyword as well. That's the first thing that you do. So search by keyword, well, full text search supports that. So I've typed in my keyword, I've got a list back of 10 documents, now what do I do with them? Well, if those documents are great big Word documents, you're not going to go through and read each one, right? What you really want to ask the search engine is you want to ask the search engine, if these are the 10 documents I got, why did I get those documents based on that search? If I search for the word SQL, why do I get these 10 documents first? And so this is find the most relevant key phrases. So there is a thing in semantic search that allows you to find the most relevant key phrases. Once you've found the most relevant key phrases, you might say, okay, I really only want to use document number 1, document number 3, and document number 7. But what I'd really like to do is find documents that are like document number 1. So if document number 1, for example, is the one I want to look at right away, I also want to find documents that are like that one. Imagine that if you had a resume, a bunch of XML resumes, and you had the perfect employee, right? You might be the perfect employee, sir. And we want to find somebody that's exactly like you. You can actually find the closest documents by relevance. And once you find a set of close documents by relevance, then you want to find the reason why the search engine considered those to be the same, right? Or considered them to be close. And in fact, I've even seen people that find the closest documents by relevance to look for plagiarism in papers that people write as students, right? That's a way to do it. However, at least read the paper if you're going to, upset the student by talking about that. So the way semantic search works, and this really calls for a semantic search demo before we do this, so let's go and do a semantic search demo. By the way, this demo is a canonical demo written by one of the guys on the SQL Server search team. Of course, what would you think to do, right? If somebody said, here's a cool feature, now go make up a cool demo for it. Well, you wouldn't do songs in different languages. Only I am an idiot enough to do that. Instead, what you would do is, what, being SQL Server people? You would drag over all the SQL Server documents. Sure. And then you can search the SQL Server documents. So let's make up a database called SQL Server Articles. There we go. And we also have to make sure semantic search is registered. So you can register the database that they give you for semantic search. I'll talk about why you would do that. It's already there. And you can verify that that database is registered. Okay, it's there. I can also look for semantic search languages in here. And here I have English as one of the languages, so that's the one I'm going to use here. I'm going to create a database with file streams again and non-transacted access. And then I'm going to go out here and create a file table, just like I did before. Now what am I going to do once I've created a file table? Go open up the file table. Because I'm lazy, I'll do this, right? And we'll go refresh the databases over here, and we'll go find the SQL Server articles over there, tables, file table. There we go. Right-click on the file table and say Explore Directory, which should be empty. Go bring up another copy of Windows Explorer. There we go. And go and drag and drop our stuff in there. Now, this set of white papers I like only because it's a reference set of white papers that this guy decided to write. So imagine this as the north wind of full-text search demos, right? So we'll drag and drop those in there. Great. And now we have a table of documents we can search on. Yep, just that easy. Okay, now what do we do? Well, we can read them with select documents, but I bet that'll take a long time, and I don't want to do that. So we'll go into here. We'll make a full text search catalog again. We'll make a unique index again. There we go, and we know why we're doing that now. We'll make a search property list again, and we know why we're doing that as well. And we'll make a full text index. But for this full text index, we'll use language 1033, which is US English, and we'll also tell it to collect statistical semantics. In other words, we're going to enable it for semantic search. You can enable semantic search on a index by index basis. So there's my index with semantic search. It might take a while to index all those. I can go look at the root path and so forth if I want to play file table with it, but that's so passé. We've already done that. Let's look at the population status. And there we go. So we're still indexing this. We should be able to get 0 pretty soon. You can also check other things about population as the population is proceeding. And let's do some full text search queries on it. By the way, you can query it even if the thing isn't complete. So here, where contains the property in the title, data or SQL. So it should be able to go through all of my documents. There we go. And get the ones where the property equals data or SQL. But you've seen that before, and I only have 4 minutes left to go. And so let's actually go to the semantic search functionality. Semantic search actually surfaces itself as 3 table-valued functions with really long names. So you have to really want to use this feature to be able to spell those long names. I'm sorry. The word semantic keyword phrase table is just overkill, right? I don't really need to type that in each time. So what this does is it selects the name and the document key and the key phrase and the score. In other words, how good of a score this is from 0 to 1 from semantic key phrase table over my documents table. And basically that star there is to say I want to search every column in the documents index. How many columns do I have indexed? 1, right? The content. Okay, so let's go get the top key phrases for the entire corpus. There we go. And amazingly enough, according to semantic search, the top key phrase in there is SQL. Now, that only makes sense. So let me tell you how semantic search works. Normally, the way semantic search or a keyword search works is by using something called term frequency and inverse document frequency. You can look it up in the Wikipedia. This is how many times does this term occur in my document versus how much does this term occur in normal English that everybody speaks all the time. So obviously SQL would be a big hit there because you're getting things that do not occur in normal conversation. Only we go around and say SQL, SQL, SQL all the time, right? And things that do occur in that document quite a lot. Everybody good with that? And it actually references these with a score from 0 to 1. So notice SQL score is quite high in that case. This is for the entire corpus. Here's the key phrases for a particular paper. This is a paper on data compression. And so basically this uses the same semantic key phrase table, but with an overload that uses document ID here. And so what are the key phrases in data compression? Notice it's got some that are so good. I'm sorry, I can't run over there. So good that they actually have a score of 1. So compressed, compression, CPU, data, and page are so unusual and occur so many times in that document that they actually get a really high score. Okay, but that was the first part. Show me why the search engine picked out those documents. Now that I've got that, I've decided to use this data compression white paper because that's my favorite, and I want papers that are like the data compression white paper. So what I do is I use semantic similarity table to get papers that are the same as the data compression white paper. And this will do by score. So basically, given the data compression white paper, the titles that match, the top 10 titles that match, are these 10 titles right here. The closest one is partitioning tables and indexes. And you can see the score here is only 0.3. That's pretty strange. And so now we want to see why it thinks that data compression is the same as partition table and index. And so if we want to do that, we'll put these two together and run the third semantic search function, which is called semantic similarity details table, and it will tell you the keywords that appear in both of these things. So apparently they're the same because they use the word SQL a lot, use CPU a lot, and use compression a lot. So those are the 3 semantic search keywords, and again, they're based on a study that shows how people normally use the internet. Now, I wanted to just do, I have 44 seconds. I want to do one more thing, and then I'm going to skip blithely through the rest of the slides. This actually uses 2 internal indexes. You can use them in internal tables. And I actually have a book chapter coming out in Kaylin Delaney's book that shows how the internals of all these things work. Basically, one is called the tag index, and one is called the document similarity index. And again, how they get the tag index is that the semantic search database that you installed contains the most common words for whatever language there is. And then they rate those against the number of words that are in that particular document that they're rating. So, of course, SQL isn't a common word in English, but it is in that document. Sound reasonable? And the nice thing about that is that it actually scales linearly. Now, it only supports unigrams, which means 1 keyword at a time in SQL Server 2012, although they will talk about semantic key phrases. They have semantic key phrases of up to 1. I'm over now, so let's just go. 1, to implement a semantic search, you install the database and you specify it in full text search specification. To program it, you use the 3 functions. We looked at the 3 functions. And for diagnostics, we have extended events and extensions to the dynamic management views to support semantic search. So to wrap this up, the file stream is expanded in SQL Server 2012. It's no longer this thing where you have to have transactional version of your own program. The file table was added that's based on file stream, and this allows hybrid database and file applications, where you can use the file system with things that use files, and you can use the database with things that use databases. And full text search enhancements help this. Like I said, you can craft up a demo in about 5 minutes. So thank you very much. I'm over. What I'd like to do for the sake of the next presenter is to actually take anything other than the first question offline. So do I get one question? Who has the one first question that's cool? Sorry? Yeah, so the code from this will actually be available on the SQL Skills website, and it's under past events. And so next week, this will be a past event, and I'll put it under past event. By the way, I've written a bunch of blog entries on file table, and a bunch of blog entries on full text search, and a bunch of blog entries on how the new full text search features work. So with that, I'd like to thank everybody for coming, and I will answer questions in the back if anybody's interested.